According to the diagram, this is the center O, right? Mg is acting downward through the center O. So about O, Mg, the operation of Mg is through O only. So it has no distance of separation from the point O. So Mg will not be considered producing torque. But the other two forces, N1 is L by 2 distance apart and N2, that 2 is L by 2 distance apart. So about O, if you see the right hand thumb rule mechanism, so N1 it will give clockwise rotation and N2 can give anti-clockwise rotation about the point O. For translational equilibrium, net linear force is 0, and for rotational equilibrium, net torque is 0. Is that clear? Yes or no? So based on that, if I give you a situation where suppose a rigid rod, if I mention a rigid rod, okay, let this is be a rigid rod at rest, a rigid rod at rest, okay, and let the support given at its two ends, right? The rod is of uniform mass distribution, its length is L, right? It is having its mass M such that weight of the rod will act mg downward. Let two persons are giving support at the ends A and B. With this supporting forces are N1 and N2. Are you getting me or not? This uniform rigid rod is at rest with the support of two forces applied at the end such that the rod can maintain the horizontal equilibrium position. So according to the diagram, the two forces applied by two different men at the ends of the rods are N1 and N2, such that the rod is maintained horizontally at rest, right? So here in this case, for uniform rigid rod, uniform rigid rod is maintained at rest. The for uniform rigid rod is maintained at rest as per diagram. Then find the forces applied at its ends A and B. Find the forces applied at its ends A and B. So as per the question, as it is said that the rod is maintained at rest. The rod is maintained at rest means this rigid rod is maintaining the state of equilibrium, right? So this rigid rod will follow. This implies that this rigid rod will follow the state of equilibrium, this rigid rod will follow the state of equilibrium, okay, means both translational equilibrium and rotational equilibrium. Both translational and rotational equilibrium. Are you getting it or not? This rigid rod will follow the state of equilibrium means both translational equilibrium and rotational equilibrium, right? So therefore for translational equilibrium, right, net force on the rod will be 0. Net force on the rod will be 0. Net force on the rod will be 0. So as the net force on the rod will be 0 means the upward force on the rod, that is N1 plus N2, that will be equal to the downward force on it, that is mg, isn't it? For translational equilibrium, net force on the rod will be 0 means N1 plus N2 will be equal to mg, okay? And for rotational equilibrium, and for rotational equilibrium, net torque about center O, is 0. That means balancing torque is available on the rod about the center C, right? So obviously as we are taking the torque calculation about the center, so that means the forces acting or passing through the center O will not be considered to be producing any torque. So according to the diagram, if you check it, according to the diagram, this is the center O, right? mg is acting downward through the center O. So about O mg, the operation of mg is through O only. So it has no distance of separation from the point O. So mg will not be considered producing torque. But the other two forces, N1 is L by 2 distance apart and N2, that too is L by 2 distance apart. So about O, if you see the right hand thumb rule mechanism, so N1 it will give clockwise rotation and N2 can give anti-clockwise rotation about the point O. So these two torque by N1 and N2, so that means I can write down N1 into L by 2, that should be equal to N2 into L by 2, clockwise torque is equal to anti-clockwise torque. Since both these two applied forces, supporting forces are equidistant from the center O, L by 2 distance away. So that's why once we cancel out L by 2, so this justifies that N1 is equal to N2. We are getting it by the concept of rotational equilibrium. Is that clear? So now we do have two mathematical equations relating to N1 and N2. One is about the vertical forces 0, another one is the relation between N1 and N2. So here, therefore, applying, solving equations 1 and 2, from 1 and 2, we can write down it is 2N1 or it is equal to 2N2, that is equal to mg from equation 1. If you put the value of N1 is equal to N2 in equation 1, right? So it will be 2N1 equal to mg, or otherwise 2N2 equal to mg. So both N1 and N2 are equal in value and they are both equal to mg by 2. Is that clear or not? So we can see that by the observation of balancing forces and balancing torque, we can find the supporting forces at the end point such that the rod can be maintained at its given position because of these two supporting forces. They are providing balancing forces as well as balancing torque to the rod about the center. Is that clear?